Hi everyone, welcome back. Today we are going to discuss about the case study on level sensors and its application in HVAC system. So we will see the introduction of this case study. A level sensor, or it may be called as a level transducer, which are used in the HVAC, like heating, ventilation and air conditioning system. So here this level sensor, level transducer is a device which is used to measure the level of liquid or other fluid within a container or tanker, or it may be a reservoir. So here the measurement is converted into the electrical signal and can be used for the monitoring, controlling and for the automation purpose of heating, ventilation, air conditioning system. So here a level transducer, it plays a crucial role to maintaining the proper functioning and safety of various HVAC components which are involved in the fluid management. And there are two classifications. One is direct and indirect level measurement, and the second one continuous and discrete level measurement. So if it is a direct measurement, a liquid level is converted directly to electrical signal. This can be done with the help of some indicator. And if it is indirect method, the liquid level is first converted into displacement. After that, the displacement is converted into electrical signal. So this is the indirect level measurement. And for the continuous level transducer, so here a transducer, it measures the exact position of liquid level so that we can monitor the entire system. So the few types are ultrasonic level transducer, float element level type transducer, capacitive level transducer, pressure type level transducer, inductive level transducer and resistive level transducers, etc. So first we will see how the float element type level transducer is operating in an HVAC system. So here there is a tank. So in the tank there is some water storage. So the float element, this is a float element. Just you can look here. This is a float element. So a float element, okay, so is just above it is always touches with the water. Okay, as the liquid level increases, the float is rises. If the water flow level decreases, the float is also decreases. So the water, it causes to move the float. Once the float moves up and down, decreases or increases. So here a wiper which are connected with the float is also gets changed. And wiper, it also, if the float goes down, here the weight goes up, so that the pointer gets changed. Suppose if the float goes up, the weight goes down, so the pointer comes like this. So the resistance of the wiper gets changed. So once the resistance is changed, the voltage across the wiper also gets changed. So once the voltage is changed, so that according to the voltage we can able to measure what is the level of the water. So it is the advantage, it is very simple in construction and it is very easy to operate and work at large temperature range. But what is the disadvantage means it is not suitable in moderate pressure, and the design of float, it should be selected properly. Once the water rises, the float should be rises. The water decreases, the float should be decreases. So the proper designing of float is very important. And the next one, ultrasonic level transducer. So here There is an ultrasonic transmitted devices which is placed at the top of the tank. Here we are sending the ultrasonic signal, and it will be touches the water, and again once it touches the object, again the same signal will be reflected to the same ultrasonic transmitter. So here it works under the principle of time of flight principle. It is under the principle of time of flight. So what is the time taken to transmit and receiving the signal? So what is the time taken to transfer what is the time of transmitting the signal, and what is the time of receiving the signal? So what is the time consumed to travel the light signal? So based on the time signal, we can able to measure what is the level of the liquid in a container, or it may be a tank. That is nothing but an ultrasonic sensor. So here it is more reliable, and there is no moving parts. It is just compared to the previous method, and it can be used in high humidity. Okay, and the material density or conductivity is not affected. But what is the disadvantage? If any dust particle, it may create distortion, because while sending the ultrasonic signal, if any dust particles there, it will mislead the reading, and vibration or high noise will affect the result also. And the next one, manometer type level sensor and pressure type level sensor. So here these are the tanks. These are the tanks which is near to the tank. If it is manometer, here we are using the bottom of the tank, we are using the mercury. So based on the level of fluid, the mercury it indicates the readings. And if it is differential, here we are fixing the differential pressure transducer. So here what is the pressure which is created across the transducer, and here this is an atmospheric pressure. Just we can compare the two pressure, and after that it gives the what is the level of the water. And next, point, or it may be called as a discrete level transducer. So here we are keeping the few types of sensors. Okay, one is in topmost, one is in middle, and another one is lower section. Once the water level it touches the sensor A, now we can imagine the water is full. Now the water is reaches the sensor B. Here we can here it gives an information the water level is 50%, and if the water is it's below sensor C, now we can imagine the water level is going to dry as soon. So here this is a discrete. One is once the tank is full, or the tank is 50%, or the tank is going to dry. But in between we are not able to measure by using this discrete level transducer. And these are the few reference papers and books for this case study. Thank you.